Hello everyone, welcome back to my channel InfoSec Lab, and today is going to be another video about attacking and defending AWS services. In today's room, we're going to go over AWS VPC, as you can see right here, and how to leverage this AWS service to exfiltrate data within that cloud environment. The mission brief. Congratulations, you found AWS Credentials for a network engineer at your target. Your mission, if you choose to accept it, is to reconfigure their secure network so that you can exfiltrate the secret plans for the next generations of space weapons. The plans are all in the EC2 Instance named Engineering Wiki, and because they think the wiki is securely inside the network, is available on port 80. Reconfigure the route table, security groups, and maybe the NACLs, which is the network access control list. You can curl the EC2 instance from your AttackBox and enter the name of the secret weapon. Note, for this room, your access has been demoted to a network engineer. You can modify resources, but your ability to see things in AWS Management console is limited. You can still see the CloudShell if that's your preference. You can use the CloudShell if that's your preference. Accessing the cloud environment, no, we don't need to go over this one. You might know how to do it by this time. Assigning a public IP address on the target instance. The target EC2 instance doesn't have a public IP address, so we're going to target it from our attack box. We need to assign one. Again, before performing any commands on this room, you have to configure your AWS account first, which will be provided by your TryHackMe account. Alright, for me, let's AWS EC2 allocate trips. And we should, as usual, I'll just copy all the output of the commands I run, so I can refer back to them whenever I want to. Remember, this is public IP address. You need it for the last task. Now we need to find the ENI, the network interface for the target machine. Not every AWS CLI command requires elegant use of query and filter, so we can use the grep command in this case to get our results. So AWS EC2 describe instances, and then put it in a JSON file, instances.json. Then cat instance grep ENI. Now we attach the public IP to the ENI of the target machine. Wait, which one are we looking for? Now we need to find the ENI network interface. Okay, so we need this value right here, ENI. I'll just copy the whole thing. The key and the value. Copy, paste here. Alright. Now we attach the public IP address to the ENI of the target machine by associating the allocation ID with the network interface. Allocation ID. Where was the allocation ID? Oh, right here. The allocation ID is here. We need this value. Okay, let's try this command. Copy. I'll leave it here. Associated address network interface is going to be this one. Allocation ID is going to be this one. Okay, is there anything else we need? No, we don't need anything else. Alright, let's copy the whole command and run it. I'll make it smaller a little smaller. Open another window on your attack box and start ping against the above IP address. Okay, an error occurred when calling the associated IP address operator network. VPN is not attached to any internet gateway. What in the world is it? Okay, looks like we didn't pick the correct network interface. They had 3. So let's try one more time. Correct EC2 instances to assign. We have 3 values. How do we know which one? We try, hold on. Let's see which one we try. EC2 152. We try this one, so we have the other 2, which is this one. Yes. Copy. And we also have this one. So we try the first one, it didn't work. Let's try the second one right here. Copy, paste. Hopefully it works. There we go. Got the output. Open another window on your attack box and start ping against the above IP address. This will help you know when you succeeded exposing this private Wiki instance. File, open new tab, and then ping this public IP address, which is this one. Okay, looks like it's working. What was the value public IPv4 in the EC2 Instance allocated address response? What? Public Amazon. Alright, change the route table allowing a private subnet direct internet access. Just because your target instance has a public IP address doesn't mean that it can be reached from the internet. You also have to ensure that there's a route from the internet to the target. In this task, we'll establish a route from the internet represented by the Internet Gateway or IGW to the subnet of the target residing. To get the Internet Gateway ID, you'll probably have to get the Internet Gateway ID. You'll probably have 2 in your account. One with the default VPC and won't have any tags. The other one will have tags. Okay, let's try that. AWS EC2 describe Internet gateways. The one is for the default VPC that won't have any tags. The other one will have tags. They both have tags. What? So how do we know which one is which? So we have one VPC right here. Okay, VPC capsule Internet Gateway. So I guess that's the one. And then this one doesn't have anything. Okay, so I guess I would assume it's going to be this one. I assume it's going to be this one. Okay, hold on. Copy VPC ID equals this one. Now get the route table ID AWS EC2 describe route tables.json. Now you're ready to add the route table like so. Okay, cat route table, see what it is. It's so long. How do we know which one's which? Route table association met is full. Tag is public route table, stack set VPC capstone, public route table. This might be the one. Let's see if we have anything else. Wait, which one with the VPC that we have? 6D62F. V62F route table, that's a gateway. Nope, not this one. Child capstone public route table, nope. This one create a route table. This is not the VPC that we saved earlier. Oh yeah, this one. Association, this one. Now get the route table. You want the one with name tag VPC capstone private route table. Okay. Now it's easier. I missed that part. My bad. Public route table. Nope. Not this one. VPC capstone public route table. Nope. We are looking for the private route table associated. We can grab VP in the route table. Doesn't get anything. So I have scanned through. Okay, it's this one right here. VPC capstone private route table destination. The route table ID is this one. Now you're ready to add the route table like so. Internet gateway. So we got the internet gateway. Okay, I'm sorry, I got the VPC ID instead of the internet gateway. So I've got to do it again. Apologies. Easy to describe. Internet gateway. To the one without tags, and then the one with tags. I think we got this one from the first. RGW ID equals to this one. Yeah. Now we're going to run this command to add the route table, add the route to the route table. Copy. AWS EC2 create route table ID is going to be this one. Destination side of block 00. Okay, anyway, gateway internet ID is going to be this one. Now copy the whole thing, paste it here. Return true. Okay. By specifying a destination side of block 0.0.0.0/0, you're telling the route table to send all traffic to the internet gateway. If you run the command AWS describe route tables, you should see this one as the routes to the private subnet route table. AWS EC2 describe route tables. Right here, destination side create route active. Let's double check the route, the gateway ID and the route table. Route table is 73A7. What? Is it not this one? The gateway is correct. Interesting. Right here. The route table is 73A7. Okay, this is the correct route table ID. Let's confirm. Okay, we got the correct internet gateway ID 549B. Yes, this is the one. This is gonna be the one we look for. Create route state is active. Okay, so this one's present, meaning that we have successfully added the route to the route table. What was the name of the internet gateway? VPC. Yeah. VPC capstone internet gateway. Copy paste. Okay. Clear. Continue. Okay, now modify the security group to allow access to the world. You have now established a route to the target instance subnet, but your traffic is still blocked by a security group. In this task, you see the compromised network credentials to cut a hole in your firewall. to access the target instance. First, you need to find the group ID of the engineering wiki security group to ensure that it is open to allow you access. AWS EC2 describe security groups security groups.json. Open the security groups.json file and look for the group ID, the security group called the engineering wiki security group. Secure. Right here, engineering wiki security group. Can we try another command? Okay, let's get the information first. Next, create a security group rule to allow all traffic from anywhere. Let's see the command. Okay, of course we have to get the security group ID. Just want to make sure I get the correct one. So this is for the default VPC security group. Okay, this one is for the group ID engineering security group. The group ID is going to be this one. Copy and paste. SG ID equals this one. I wonder if we can try this command. Query and here we go. What was it? The group name. Okay. You know what? I'll figure it out later. What I was trying to do is like I was trying to use run an AWS CLI to directly filter out the security group with the group name. No, with the name of engineering security. With the group name engineering wiki security group. I was trying to use AWS CLI, but I kind of forget how to do it, so I'm just gonna be waste of time. Right now, I'll just focus on the material, and then if I have time later, I'll show you guys, okay? Because the security groups are stateful, you use the command authorize security group increase to create a rule allowing all ports of 0 to 65, 535 from any IP address. Okay, protocol is O. Okay, let's run this command right here to modify the security group. What is the description of security group? You just compromise. Group name. Description is super secure security group. Right here. Okay, fix the NACLs to allow access on network access control list. Boy, this engineering wiki has a lot of defenses. Luckily, we have a hot knife of compromised credentials to cut through them. Our next layer of defense to cut through is the network access control list, or NACLs. Let's get the information we need about them. AWS EC2 describe network ACLs. NACL.json. Look through the NACL.json file for the NACL call, the VPC capstone private subnet NACL. You need to find the NACL ID beginning with ACL of the one you want to edit. The ACL entries for your target NACL should look like this. Entries, okay, cat ANCLs, and then VPC capstone private. Entry. Association. Subnets. Entries. Side block, rule name, side block. Is default network access, BPM, owner association. No. Subnet. Oh, there. Here we go. This is the one. Copy. Alright, as you can see from the above, only the VPC CIDR range 10.100.0.0/21 is allowed to talk to this private subnet, which will not work for our evil purposes. There are 2 rules defining the egress of our outbound traffic, and 3 rules for the inbound or ingress traffic. The last rule for both ingress and egress, rule number 32.3.27.67. This one, okay. It's always denied. The following command will create a new rule at the top of the evaluation list. Rule number 1, to allow all traffic protocol -1 from anyway side of block 000.0/0 to the subnet. Okay, again, we're gonna copy the command and modify it with the correct network ACL ID. So create network ACL entry, side of block ingress protocol. Okay. Rule number network ACL ID is going to be this one. Repeat the whole thing. Paste. Note, the above command will not return any output. Yep, but wait, there's more. It is important to remember that NACLs are stateless. Just because you're allowing your traffic in doesn't mean that the return packet are allowed to back out. So let's create an egress rule. Okay, egress rule is going to be similar. Okay, let's see what's the difference. Create an entry, okay, everything. Okay, this is ingress, this is egress. The rest is the same. You allow all the traffic, which is protocols -1, and the rule action is number 1. The rule action is allowed. The rule number is all number 1, meaning that it's always on the top of the network access control list. So it's the number 1 priority to follow. Run this one. Okay. Bingo! Our ping window should now show me that we can hit the public IP address we assigned to the engineering wiki. We're almost done here. If you want to see what the new IP NACL look like, you can run the following command. AWS EC2 describe network ACLs filters name equals network ACL ID values equals this one. Okay, we have successfully, where was it? Scroll down. We have rule number 1 right here. Okay, egress true, allow all the traffic from anywhere. Allow all the traffic from anywhere. This is egress. Where's the ingress? Which is the outbound traffic. Where's the ingress? Then we have ingress. Oh, over here, egress equal false, meaning it's an inbound traffic. Okay, so now we have verified that both rules are added to the network access control list. How many subnets are associated with the VPC capstone private NACL? How many subnet? 1 subnet. 2 subnets. So 2. Whoops. Mission success. You've succeeded in exposing the previous secure engineering wiki. Open the public IP address you could allocate to download the circuit plans and answer the questions below. You can use the curl or web browser to access the public IP address you allocate in task number 2. So what was the IP address? This one. Copy. Curl HTTP. Again, it was specified. It was mentioned at the beginning of this room that it was on port 80, so it's going to be HTTP, not HTTPS. So what do we have? Secret engineering wiki, secret engineering explode source. Okay, the answer to the question is okay. It's going to be this one. And here we go. We have successfully exploited, or we have successfully exfiltrate data from AWS VPC. Specifically, we managed to change a lot of configurations of the EC2 instance from a private subnet to be exposed to the public internet by changing the security groups, changing the route tables, and then also changing the network access control list. Now keep in mind that these are important network concepts that we have to know in AWS, because they can actually help you a lot. They can actually help you a lot during your AWS penetration testing. All right, I know this room may sound a little bit confusing to a lot of you guys, but it's not that hard once you get familiar with that. If you have any questions, again, please feel free to reach out to me. I'll be happy to help you. And I'll see you again then. Thank you. Bye.